Okay, last one got cut off, and that was my fault. Went over my 15 minutes, and so just want to make sure that we are okay with those answers. The 17 for chlorine came from the protons, and the 37 came from the protons plus the neutrons, so right there. And then the chlorine symbol, we looked it up, and then the charge was protons minus electrons equals charge, and I wrote that right there to kind of help you out. So hopefully that cleans that up. Okay, let's go on to this one here. Wrote down a few things already, and we will start here. And so average atomic mass or atomic mass. So these terms here are so it's either called average mass or it's called atomic mass or it's called average atomic mass. So any of those are fine. So I wrote average above uh, the word atomic mass so that you could see that sometimes it's called average atomic mass. Now maybe not as much in that international format, but a lot of times we use that term average atomic mass. So what is that? It is a weighted average um, of an element's isotopes. So elements have isotopes, right? So carbon can weigh 12 or 13 or 14. But when you look on the periodic table, the number is a decimal. So 12.01 right there for carbon. Cobalt is 58.93. So it's a decimal. And that's because it's taking into consideration things that weigh a little bit more or a little bit less. And so when you take things that weigh 12 and 13 and 14, what happens is that the weighted average is how often they're found in nature. So if 95% of something is what you find in nature, then it gets weighted more heavily towards the average atomic mass. So it's kind of like your grade, right? So you have a grade in this class. And so currently the grade scale we're running is you've got a 60% of your grade is your tests, your assessments, and then your other percent, 40% is everything else. So you've got to take your grade in the 60%. And so you take your grade times 0.6, and then your grade, so your percent times 0.6 and your percent times 0.4, and add those up, and that's your grade. So, like if you have an 85 in the 60% and a 65 in the 40%, when we take 85 times 0.6 plus 65 times 0.4, that gives you your grade. Well, this is no different, right? So the way that we find that number is no different. So you just take mass times percent plus mass times percent, and you add them up. So it's really, really, really easy. So let me show you how to do that here. Oops, don't want to do that. All right, there's example one. So right here, it's talking about, it said that all of the masses on the periodic table are based on the concept that carbon is 12. You don't need to know that. It's just kind of something hanging out there. So remember, when we put these things in our calculator, then we're going to have to divide by 100 to get them into a decimal form. All right, so if I want that in a decimal form, it's going to be 0.7553 for my calculator. So here's the mass. Atomic mass units is the same as grams. All right, so there's your mass. And then over here, we're going to run this through. So we're going to take 34.97, and we're going to multiply that by the 0.7553. And then we're going to bracket that, and we're going to add it to the other side, which is the 36.97. And we're multiplying that by the 0.2447. Okay, how do we know if our answers may be right? Well, here's a pretty easy way to look at it. It better be between the high value and the low value, because remember, averages need to fall in the middle. If it doesn't, we probably didn't get it right. So let's go ahead and plug it in. So let's take 34.97 and multiply it by 0.7553, hit enter. And then we're going to add that to, in parentheses, 36.97 times 0.2447, close parentheses. And I got 35.4594. So if I clean up my sig figs a little bit, go down to 4, then how about 35.46 atomic mass units or grams per mole, either way. Well, it's chlorine. So let's go ahead and look chlorine up over here. And there you go, 35.45. I think I'll take it. It's only off by 1/100th. All right, so that's pretty good. We can feel good about that, right? So pretty easy skill. Shouldn't be too tough for you. Not a very good happy face. There we go. Give him a little squiggle. I'm going to give him a nose, ear. Okay, there you go. That looks pretty good. All right, here we go. All right, so let's go over here and let's take a look at a little bit harder skill. And this is, we're not going to try to find like the answer. We're going to be trying to find one of the percents, right? So it'd be kind of like figuring out one of those percents for your grade. So instead of finding the answer, we're going to be looking for what the percentages are. And so it would be kind of like trying to find the 60 and the 40. And so we're going to do that. So this formula here is trying to show you what I'm going to do, but the best way is really to look at the examples here. And so we're going to set this up, and the key thing is that you understand that I'm going to put the heavier isotope with the X, and the lighter isotope is going to go with the 1 minus X. And so this formula here is trying to show you what I'm going to be doing, but I never feel like the formula itself does a very good job of showing this. And so basically what I'm going to do, take the mass and then set that equal to X. So I'm going to be basically multiplying it by X, and that's going to give me the bigger piece. And then the 1, the reason there's a 1 minus X in there is the 1 is going to represent the concept of 100%. So you're going to find that this only works if you have 2 percentages. It won't work for 3. So, but you only get 2 on the test, so not a big deal. Okay, we got copper 63 and we got a weight. And we got copper 65 and we got a weight. And then we know the total, they say the tabulated atomic mass is 63.546. So we've got 2 isotopes. One weighs 62.9298. One weighs 64.9278, and the overall mass is 63.546. It wants to know the percentages, which you cannot look up on the periodic table, which is why this is a better question. Now, I want to point out that if they did not give you this, say they did not give you how much copper weighed. And you're like, I don't know how much copper weighs. Well, yes, you do. Go over to your periodic table, look at copper, 63.55. This is just 1 decimal more accurate. So if you don't have this value, you could look it up on the periodic table. I will tell you that it is more likely that they don't give you that and they want you to look it up. Okay, so be careful with that. Okay, so take good notes here. So what I'm going to do, take the heavy one. And I'm gonna set that one. I'm gonna give myself a little more space. So I'm gonna go 64.9278, and I'm gonna multiply it by X. All right. I'm gonna add it. So this is gonna be the bigger percentage. All right. Or sorry, the bigger weight, not necessarily the bigger percentage. And then I'm gonna take and so this is you may want to make a note that I always put the heavy one here. So this is the heavy one, or heavier. Okay, then over here, I'm going to go I got the copper 65. So the small one is 62.9298. And I'm going to multiply this one by 1 minus x. And then we're going to set the whole thing equal to what it weighs on the periodic table. All right, so we're going to go ahead and do that. And so then this would have been the light one. So I got the heavy one and the light one. Okay, so now you got to do some math. And we're going to have to simplify all of this out and do a little bit of distributing. So I'll change colors real quick. Give myself a little more space. So it's going to be 64.9278x plus, so it's going to be 62.9298 minus 62.9298x equals 63.546. Okay, so now we need to simplify the x's, right? So this one here, take that one minus that one, because they're both x's. And when you do that, you're going to get not the best looking color there. Let's go a little darker. Let's go back to the red. Okay, so this is going to be 1.998x when I simplify that. Okay, and then I'm gonna take this and put it on the other side of the equation. So I'm going to take 63.546 minus the 62.9298. Right, so I'm just going to simplify that. So I'm going to have the 1.998x on this side equals, and when I simplify those, I'm going to get 0.6. Oh, that's not a very good point. 0.6. Still not a very good point. There we go. 0.6162. So now we're going to solve for x. So when I solve for x, run through your calculator, 1.998. So we're going to take 0.6162 divided by 1.988. And we're going to get 0.3084. This is a percent, and it goes with the x. All right. So what we want to remember is that this is for the heavy one, right? Because that was the x, and so want to make sure that we remember, hey, this goes with the heavy one, and so if we think about percentages, we're just going to multiply this by 100, and that's going to give me a percent. So I'm going to run out of space here, so I'm going to kind of go up to this corner up in the upper left. So our heavy one was the copper 65. All right, so the copper 65 is the heavy one. And so the copper 65, if I multiply this times 100, that's going to equal 30.84%. Okay, so the copper 65 is 30.84%. So that means that the other element, remember I said there can only be two, is going to be 100 minus 30.84, which is going to equal the remainder. So we take our calculator, 100 minus 30.84 and 69.16. So that's going to be the copper 63 equals 69.16%. Okay, so you got to remember that the x, the one that is heavy, is what the answer spits out. That's the percentage you get. The other percentage, you take 100 minus. So, all right, pause it here.